As we've seen, we can use the equivalence laws that we've laid out to prove that specific pairs of formulas are equivalent to each other. So let's work through one more example. This time, let's prove that P or P and Q is equivalent to P. How can we go from a formula that has both P and Q occurring in it to a formula that just has P in it? Well, we previously showed that the formula P and Q or P and not Q is equivalent to P. That equivalence takes us from a formula with both P and Q in it to just plain P. So perhaps our strategy should be to show somehow that P or P and Q is equivalent to P and Q or P and not Q, and then we can get from there to P. But how can we show that P or P and Q is equivalent to P and Q or P and not Q? Let's consider again that equivalence that we proved previously, namely that P is equivalent to P and Q or P and not Q. That means that wherever P occurs in a formula, we could substitute in P and Q or P and not Q. So in particular, in the formula P or P and Q, we could substitute in P and Q or P and not Q for that first occurrence of P. And that would give us P and Q or P and not Q or P and Q. And that formula we can show to be equivalent to P and Q or P and not Q. Before we go through the steps properly, let me go through them a bit loosely just so you can get the underlying ideas behind the rest of the proof. So first, notice that the formula P and Q or P and not Q or P and Q can really just be seen as a disjunction with 3 disjuncts rather than 2. We can see it as saying P and Q or P and not Q or P and Q. Moreover, since it doesn't matter what order the disjuncts appear in a disjunction, we could rewrite that formula as P and Q or P and Q or P and not Q. And now note the double occurrence of P and Q. It occurs as both the first disjunct and the second. To assert P and Q or P and Q is just to assert P and Q. So the formula P and Q or P and Q or P and not Q is just equivalent to P and Q or P and not Q, which is precisely the formula that we wanted to arrive at. Okay, now let's go through the steps properly. So first we say that P or P and Q is equivalent to P and Q or P and not Q or P and Q. We know that those formulas are equivalent because of our previous proof showing P to be equivalent to P and Q or P and not Q plus the law of substitution. If you want to rely on the results of your previous proofs like this rather than going through all the steps again from scratch, that's fine. We'll allow that. Next, I ultimately want to get those 2 occurrences of P and Q together into a disjunction that says P and Q or P and Q, which I know I can reduce to just P and Q. So I'm going to use the second of the commutative laws to bring the second occurrence of P and Q to the front next to the other occurrence of P and Q. So I'll say that P and Q or P and not Q or P and Q is equivalent to P and Q or P and Q or P and not Q based on the commutative laws. We've just taken the formula P and Q or P and not Q or P and Q and swapped the order of the 2 disjuncts. So the small one now comes before the big one. Now we use the first of the associative laws to regroup things inside our big disjunction so that the first P and Q is now grouped together with the second P and Q, and the P and not Q is on its own as the second disjunct. Now the second of the idempotent laws tells us that P and Q or P and Q is equivalent to P and Q. So the idempotent laws plus the law of substitution tell us that P and Q or P and Q or P and not Q is equivalent to P and Q or P and not Q. And finally, the proof that we did previously tells us that P and Q or P and not Q is equivalent to P.